a daily sales query timed out after 60 minutes, blocking all downstream reports. The developer scaled up warehouses, but the real culprit was a materialized view that wasn't even being used. We'll explore Snowflake Materialized Views and automatic clustering, two features that pre-compute results and reorganize data to dramatically speed up queries on large datasets. Materialized views store pre-computed results in a dedicated storage layer and automatically refresh when the base table changes. Unlike standard views that run the query each time against the base table, materialized views give you instant access to aggregated data from that stored snapshot, making them ideal for dashboards and reports that require low latency. To create a materialized view, use the Create Materialized View statement followed by a select query that references a base table. The query must be deterministic, no current timestamp or similar functions. You can also add a clustering key to the view itself for further optimization. Here's a real example. We create a materialized view that aggregates daily sales by product. Then we query it with a filter on sale date. The view returns pre-computed results instantly. Managing materialized views involves listing them with show, checking refresh history in information schema, forcing a refresh with alter, and dropping them when no longer needed. Regular monitoring ensures they stay efficient. These commands let you list, inspect, refresh, and drop materialized views. Use them to keep your views healthy and up to date. As data inserts land, automatic clustering reorganizes them on disk based on your clustering keys. That cuts the data scan for queries with range filters, like where date between. Snowflake handles the clustering automatically. We create a table with a clustering key on sale date. You can also add clustering to an existing table. Use system $clustering depth to check how well clustered your data is. A depth close to 1 is ideal. For maximum performance, combine both features. Cluster the base table on columns used in the Materialized Views group by or where clauses. You can also cluster the MV separately for additional optimization. This speeds up both the view refresh and queries against the base table, enabling fast queries even for large datasets. In this example, the base table is clustered on sale date, and the materialized view also has its own clustering key. The query filters on a date range, benefiting from both optimizations. Snowflake provides tools to monitor performance. Use information schema to check if queries use materialized views, view clustering history, and track credit consumption. Regular monitoring helps you adjust keys or drop unused views. These queries use DATEADD and query history to verify materialized view usage and check clustering history. If automatic clustering isn't keeping up, you can manually recluster the table. This is the chain reaction that unfolded. The daily sales aggregation timed out because the materialized view didn't match the query exactly, so Snowflake ignored it. The base table had no clustering key, and data was inserted randomly, causing full table scans. The fix was to create a materialized view that exactly matched the query pattern, add a clustering key on the date column, and enable automatic clustering. This allows a fast scan of the data, and the query ran in under 10 seconds. Success. One mistake we see often: creating a materialized view that doesn't match the query exactly. Here, adding a sale date filter that isn't in the MV definition forces a full table scan instead. The fix: remove that mismatched filter so the query aligns with the MV, letting Snowflake use it. Clustering on high cardinality ordered barely groups data, leaving high depth. The fix: cluster on order date instead. Its lower cardinality groups rows by date, reducing scan depth for range filters. If you only select clustering depth without a threshold check, depth can creep up and scan more data. Instead, use a case expression to flag when depth exceeds 3, so you recluster proactively. To debug issues, first verify the materialized view exists and matches your query. Use explain to see if the view is used. Check refresh history and clustering depth to identify bottlenecks. Let's review common interview questions on this topic. Knowing these will help you demonstrate your Snowflake expertise. Let's answer some frequently asked questions to solidify your understanding. To recap, Materialized Views store precomputed results and auto-refresh, while clustering reorganizes data for faster range queries. Combine both, monitor regularly, and always verify with Explain. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.